Discussion question D2. The question says that at Liverpool the tide is nearly sinusoidal and it has a period of 12 hours 40 minutes. So I know that T equals to 12 hours 40 minutes, which works out to be about 760 minutes. And if you want to find it in terms of seconds, it's 45600 seconds. Okay, and since it's almost sinusoidal, I can look at the diagram. It's actually a sine curve. X equals to x naught sine omega t. So I know the equation is, the amplitude is 3.7. Sine omega in this case is 2 pi t, where t we have already found. So the ship captain know that the depth of the water the ship requires is about 5 meters. So it's only during this period of time that the ship can pass through the Liverpool water. So in that case, in your diagram it was already stated I want T1 and T2. Okay, at this point I also know that since this is 5 meters, this should be 5 minus 3.7, so it's 1.3 meters. So I'm going to put this in. So this will be 1.3. Okay, so if I do solve it, then I'll get t equals to 2610 seconds, or t equals to 20190 seconds, and these two answers are valid because it will be T1 and T2. So the length of time will be equals to 20190 minus 2610, so you get a value of, if I convert it to minutes, it will be 17580 seconds, or 293 minutes. Okay, the next question asks, what is the rate at which the tide is rising? So the rate at which the tide is rising is actually the velocity. So the velocity is the differential of this equation. So it's actually omega x naught cosine omega t. So at this point in time, I want the velocity either at this point or at this point. So I'll just substitute the value in. So omega again is 2 pi t, where t is already found. X naught is 3.7 meters. Cosine omega 2 pi t, and the time here is, let's say I use 2610 seconds. Okay, so if you work that out, you should get a value of 4.77 times 10 to the power minus 4 meters per second.